With this class, when we wrapping up a section right before an exam, we get word problems. So, sorry, but here we go. Okay. These ones actually shouldn't be too bad. All right. So what's a formula? Let's get our starters done because you're going to need these. What's a formula that relates distance, rate, and time? What's that formula? Distance equals rate times time. Right. Now I will always write it this way. I will always write it rate times time equals distance, and you'll see why later because of the way I set these up. So rate times time equals distance. Good. Area of a rectangle. Length times width or base times height if you learned it that way. Either way is fine. Triangle. Half of that, right? 1/2 the base times the height. Okay, circle. Pi r squared. With r being the radius. Good. What's the Pythagorean theorem? A squared plus b squared equals c squared. Now what can we use the Pythagorean theorem on? What kind of triangles? Right triangles only. Good. Okay, so what is the area of this rectangle here? XY. What about this triangle? 1/2 XY. You guys are so smart. Okay, distance formula. D equals, big old square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so what is the distance between 0, 0 and 4, 3? Okay, plug and chug, right? So we get 4 minus 0 squared plus 3 minus 0 squared. So this gives us 16 plus 9, which is 25, and the square root of 25 is 5. So that is 5 units. Okay. All right, what's the distance between 0, 0 and xy? Square root of x squared plus y squared. Yeah, just like that, okay? Now, some of the questions, again, on Math Excel, which you noticed last time, are going to have these parts where you're supposed to use a calculator. Obviously, we can't use the calculator anymore, so just skip those, okay? And I know where they are, and so I will credit you accordingly on your assignment. So you're not going to get 100% on your assignment, okay? Well, on Math Excel, but I will give you, if you've done all the non-calculator parts, then I'll give you 100 for the assignment, okay? Make sense? I mean, if you got a graphing calculator, you want to mess around with it, knock yourself out, but it won't affect your score, okay? All right. So let's rock and roll here. So it says let P equal xy be a point on the graph of y equals x squared minus 8. Express a distance from D from P to the point 0, negative 1 as a function of x. What is the distance if x is 0? What is the distance if x is negative 1? Okay? So I'm gonna just quickly sketch x squared minus 8 here. So what's that? So by the way, what's that doing to my graph? Shifting it where? Down 8, right? So my vertex is down here. So you go right 1 up 1 squared, right 2 up 2 squared, left 1 up 1 squared, left 2 up 2 squared. So my graph's going to look something like that. Okay? All right, so we want to express the distance from D to P. Okay? And again, P is xy, so we need to figure out that distance. So our distance then for part A is the square root of x minus 0 squared plus y minus 1 squared minus a negative 1 squared. Okay? So everybody understand what I've done so far? Maddie, all that stuff, it's on the back counter, all the lecture notes. Oh, gotcha. Okay, that's right. You and I talked about that yesterday. My fault. Okay. Okay, so that is the distance, but now it says we want it as a function of x. Okay? So if we want it as a function of x, what do we have to get rid of? We have to get rid of y. okay? We can't, if we want it as a function of x, we can't have y in there. So now, and here's how we're going to write this, okay? Because we want it as a function of x. So we're going to write it as d of x, okay? Now, how am I going to get rid of y? Nope. Okay, what else are we given here? Look right here. Oh, we're given y equals x squared minus 8. So guess what I can do? I can substitute. Okay, so we're going to take that bad boy right there, and we're going to plug it in right there. Okay, so now my distance as a function of x is this. It's x squared plus x squared minus 8 plus 1 squared. And now it's just a matter of simplifying, okay, which we will do. Okay, so now our distance is the square root of x squared plus x squared minus 8 plus 1 is x squared minus 7 squared. Now we quickly FOIL that out. And I'm going to do it quickly because you guys should all be able to multiply two binomials together. So that gives us x to the fourth minus 14x squared plus 49. And we got our x squared out front here. Now we combine our two like terms. So our final product then, our distance as a function of x is x to the fourth minus 13x squared plus 49. Now, why would we do that? Okay, reason. Now we don't even have to know what y is in our equation to find the distance. Okay, all we have to know is x, and that's kind of cool. Okay, so now we look at part B. What is the distance if x equals 0? So guess what I do? Plug 0 in for x. Hey, so what do we get? So what's our distance if x equals 0? It's the square root of 49, which is 7. Okay, what is the distance if x equals negative 1? Plug it in. What's negative 1 to the fourth? 1. Minus 13 times negative 1 squared, which is negative 1, or negative 13. So we go minus 13 plus 49. Okay, so let's see. 1 plus 49 is 50. 50 minus 13 is 37. So that is the square root of 37. Or 6.2-ish, 6.1 even maybe. That's how we do it. Okay? Okay, I know it's long. You got to hang with me, okay? Because the Slick loves these kind of problems, and so does MathXL. So you're going to see this stuff a lot. So a rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared. You're probably going to need to know that and use it. That's why they give it to us, right? Okay. So, and then another is on the origin, a third is on the positive y-axis, and the fourth is on the positive x-axis. So you can see our little sketch right there, okay? Now express the area of the rectangle as a function of x. So we know the area of the rectangle, first of all, is simply x times y, correct? It's our x value here times our y value here. That's the area of our rectangle, okay? But now again, we want it as a function of x. So a of x is equal to, I got to get rid of y. What am I going to do? Yeah, take our equation, take that, and plug it in right there. So it's x times 25 minus x squared, and you can leave it like that. If you want to run your x through, distribute that through, that's fine. Leave it like that though, okay? All right, now, part B here, express the domain of A, okay? And this is kind of a big one. All right, so what can't this be? It can't be negative, right? An area can't ever be negative. Does that make sense? Okay, so what do I know about x then? So for my domain, x has to be what? It has to be greater than 0 because of that right there. So I know that for sure. Okay, so x has to be greater than 0. But what can it be bigger than? Actually, we can put greater than or equal to 0. You can technically have an area of 0. So 0 is okay, but anything bigger than 0, but anything bigger than 0 screws us up, okay? So x is greater than 0, but what can it be greater than as well? It can't, yeah. It has to be less than 5, correct? Because if it's bigger than 5, what's going to happen here? That's going to make this thing negative, right? So if it's 6, okay, this gives me 36, 25 minus 36, that's bad, right? It's negative, so we can't have a negative area. So what is the, so somebody specify the domain of this rectangle. X is greater than or equal to 0 and less than or equal to 5. Good. Yes?
So is that negative, like attached to the x? Like if x was negative, wouldn't it multiply to be positive?
This one would, right, but this one wouldn't, because that's just an x. So if x is negative, it screws us up here. Okay? So, your domain here, okay, to officially write your domain, x is greater than or equal to 0 and less than or equal to 5. That is your domain. Okay, what does that look like in interval notation? Because that's probably what you're going to have to do. Parenthesis bracket. Bracket 0, comma 5. Good. Nice job. Okay. And then again, MathXL will ask you to graph it and find the value. Don't worry about that because you have to do that on a calculator. Okay. Hate Fridays. I mean, I love Fridays, but I hate Fridays. Okay, so similar scenario, except for now we're dealing with a right triangle. Okay, one vertex on the graph, y equals x cubed. Bless you, where x is greater than 0, and at x, y, none at the origin, and third on the positive y-axis, blah, blah, blah. So there's our situation. Okay, express the area of the triangle as a function of x. Okay, so in this case, the area is going to be 1/2 times x times y, correct? Okay, because my base is x and my height is y. Okay, so but I want my area as a function of x. So what do? You know the drill. Plug it in. So we get 1/2 x times x cubed, which gives us 1/2 x to the 4th. There's the area as a function of x. Sweet. Is that all right? Okay, so a wire of length of x. So we've got some wire, it's x meters long or centimeters long, whatever. It's bent into the shape of a circle. Express the circumference of the circle as a function of x, and express the area of the circle as a function of x. Okay. So we're going to take this wire, we're going to bend it. All right? So what is the circumference of a circle, by the way? Yeah. So the circumference is 2 pi r. Okay? Now, what is the circumference of the circle? In this case, yeah, it's just x. Okay? So x equals 2 pi r. Okay? Now, you know what? To finish off A, we got to figure out B first, because we got to get rid of R. Okay, to get our circumference. Okay? So, time out for a second. Okay? Let's do part B. Well, no, that's just x. Yeah, so C of x, the circumference with respect to x is just simply x. Okay, sorry. I'm trying to make this way harder than I need to. Okay, now let's express the area in terms of r. So the area, what's the area of a circle? Pi r squared, but we need this in terms of x. Right, so we need the area with respect to x. Okay? Well, what do we know about the circumference, right? So what does r equal in this case? R equals x over 2 pi. We okay with that? Okay, so now I can take that and plug it in right there. Okay, so my area with respect to x then is pi times x over 2 pi squared. Now let's simplify that. So we get x, or pi times x squared over 4 pi squared. Now what can I do? Can cancel what? Cancel a pi. So now we get x squared over 4 pi. There is your area with respect to x. Okay. So circumference with respect to x is simply x. Area with respect to x is x squared over 4 pi. All right, so two cars leaving the intersection at the same time. Come on, we got to have, our cars leaving the intersection, trains, meeting, all that stuff, right? You kind of have to do that in math. It's a rule somewhere. I know it is. All right, one is headed south at a constant speed of 30 miles per hour. One is headed west at a constant speed of 40 miles per hour. Express the distance d between the cars as a function of time. Okay? So, here we go. There's that one. There's that. And we're looking at that right here. This is what we're looking at right here, what we want to find. Okay? So, let's think about it. So, it's as a function of time. Okay? So what is the distance of this car going to be right here, the car traveling west? Okay, it's traveling what's its speed? 40 miles an hour, right? So remember, distance equals rate times time, correct? So what is its rate? 40. So its distance is going to be 40t. So this is 40t right here. So what's the southbound car's distance going to be? 30t, correct? Now, what theorem could we possibly use to figure out what we need? All right, Pythagorean theorem, right? We'll call this, I don't know, we'll call this capital D. So that distance is simply d1 squared plus d2, or I should say maybe d east and or d west and d south squared. Okay, so that gives us 40t squared, oh, that's d squared, plus 30t squared. So now the distance is going to be the square root of 1600t squared plus 900t squared, which gives us 2500t squared, and the square root of that is 50t. There you go. That's your distance with respect to time. Okay. Whew. Thanks for hanging with me today, guys.